Assalamualaikum warahmatullahi wabarakatuh, and a very good day I bid to Dr. Marayati. We will present about our group project which entitled Wind Energy Potential Mapping for Jemaluang Mersing. It will be presented by me, Nur Jasmine binti Raoub. I'll present about the introduction. Next is Nur Atikah, she will present about design. And next is Hanna Najiha, next is Wan Nur Aiman, will present about impact. And lastly, Hanna Najiha will present about the conclusion of the project. In introduction, this is the content of my introduction. First of all, I'll present about the project location, which is at Jemaluang, Mersing. It is located at southern part of Peninsular Malaysia. Jemaluang is a town and mukim in Mersing district, Johor, Malaysia. The area covered is 134 kilometers square and it is 30,717 acres. Next, it have 11 nearby village. It also wet and humid condition with mean daily temperature is 31 degrees Celsius and nearly 70% humidity. And last is located near to the sea that cause influence by the effect of the sea breeze and land breeze. So this is the map of Jemaluang Mersing. Have few facilities. So it can be said that Jemaluang is a small town. Next is the basic power system topology based on renewable energy and also based on township area. So basic power system topology based on wind turbine, first of all, is divided into two conversion unit, which is mechanical power conversion unit and electrical power conversion unit. Mechanical power conversion unit convert from wind turbine to wind generator, and electrical power conversion unit convert from generator to the grid. Next, the output electrical power have three types, which is little size up to 2 kilowatt, medium size up to 2 to 100 kilowatt, and giant size 100 kilowatt and above. Giant size usually accustomed to generate power for distribute function, and it is mostly used to give power in central grid. Next, we have a few types of wind generator. First of all is squirrel cage induction generator. Next is wound rotor induction generator. Next is permanent magnet generator, and lastly synchronous generator. As for synchronous generator employs direct current windings to provide rotor magnetic fields. The rotor direct current field is controllable in synchronous generator. The controllable direct current field in the rotor offers control on the output voltage for the synchronous generator. And mostly synchronous generator is used for fossil fuels of nuclear-based generations. So we choose synchronous generator, which will later explain by Atikah. Next is basic power system topology in Mersing. In Malaysia, most of the energy sources are from coal and hydro. These are non-sustainable energy. Malaysia have its own national grid for electrical transmission. Hence, Jemaluang will consume electricity from the same national grid. It is mean that Jemaluang is not a stand-alone power system. Next, hence, it can be said that coal and hydro are the main sources used to generate electricity to Jemaluang. As for energy demand in Malaysia, in 2010, total generation was 21,051 megawatt, and customer during that time was around 7.5 million. Next, maximum energy demand was 50,072 megawatt, and in 2017, Malaysia has approximately 30 gigawatt of electric generation capacity. It can be forecasted that in 10 years, the energy demand will increase 3.5% and further increase for 2.7% for the next 20 years. Hence, it can be said that the energy demand in township area, which is at Jemaluang, doesn't have high energy demand. So we can say that Jemaluang will only need a turbine with 100 kilowatt energy capacity. That's all from me. I will invite Nur Atikah to present about design. Thank you.
I will explain more on the design of the wind turbine. This is the maps of the Mersing Johor. The placement of wind turbine is at the southern state of Peninsular Malaysia, which is Mersing, Johor. The town nearby is Jemaluang, which is 13.64 km from our wind turbine station. Why we choose Mersing? There is a reason why we choose Mersing as our wind turbine station. Mersing is known as the highest mean monthly wind speed for Malaysia in overall. Here is the graph to prove that Mersing is the highest among 14 stations in Malaysia. This is the power plant plot diagram. Wind turbine used near homes are commonly in the 1 to 10 kilowatt range but can be larger. They can be used to partially offset load or support a completely off-grid home. Small wind turbine can be used in residential settings to directly offset electricity usage using net metering, where power that is not used by the home is credited to the customer as it flows back on to the electricity system. This turbine can also be integrated with other components such as PV systems, which is for photovoltaic systems, and storage and photo converters. Here is the block diagram of wind turbine power converter. First, we have wind turbine. Wind turbine is used to convert the kinetic energy into mechanical power. For this project, we use Novento NET 100 kilowatt wind turbine since it is a high quality, reliable wind turbine at the slightly larger 100 kW. Here is the features of the wind turbine. It is suitable for the small, medium and large land holdings, sites with limited grid connection availability and quiet rural location. And then we have gearbox. Gearbox is used to vary the torque and speed according to the need. And then we have synchronous generator. Synchronous generator, the DC current is applied to the rotor winding, producing a rotor magnetic field. The rotor is then turned by external means, producing a rotating magnetic field, which induces a three-phase voltage within the stator winding. Lastly, we have step-up transformer. Step-up transformer used to boost the generating output of the turbine generator. These transformers are typically small in megavolt ampere rating and located at the base of the wind turbine. Grounding transformers are located at critical points throughout the wind farm to provide a neutral point for grounding purposes. From there, all the power is then interconnected to a collector step-up transformer located in a substation where it is transported to the electricity grid. That's all for me. For the impact, Wan Nur Aiman will.
Impact on environment and society. Wind power plants, like all other energy technologies, have some environmental impact. However, unlike most conventional technologies, which have regional and global impacts due to their emissions, the impact of wind energy systems are local. This makes them easier for local communities such as the people of Mersing to monitor and, if necessary, mitigate. According to the Intergovernmental Panel on Climate Change (IPCC), wind turbines gives off the lowest global warming potential per unit of electrical energy generated. This was proven by a result that shows wind turbine gives a median value between 15 to 11 carbon dioxide
emission per power generated. Wind turbines do cover a large area, but it is very compatible with many land uses. A utility scale wind plant will require about 50 acres per megawatt of installed capacity. However, only 5%, which is 2.5 acres, or less than this area, is actually occupied by turbines. The remaining 95% can be used by the villagers of Jemaluang Mersing to undergo farming or ranching activities. The effect of wind turbines on the ecology side is that there will be some bird kills, as birds occasionally collide with the wind turbines, as they do with other tall structures like skyscrapers. Visual impacts, which can be minimized through careful design of power plant, is part of the environmental impact. Using turbines of the same size, type, and spacing them uniformly generally results in a wind plant that satisfies most aesthetic concerns. On the other hand, the impact of wind turbines to society is recreation. Wind energy facilities create both positive and negative recreational impacts. The positive side of this is that many wind energy projects are listed as tourist sites. This will then invite tourists from other states and even other countries to come and experience seeing wind turbines firsthand. There are two types of potential negative impacts on recreational opportunities: direct and indirect. Direct impact on recreational opportunities are either precluded or require rerouting around the wind energy facility. Indirect impacts include aesthetics impacts such as addressed before. Noise is also an impact on the society around Jemaluang area. Wind turbines, despite its slow blade movement, produce a 45 decibel noise, which is slightly louder than the sound of refrigerators. However, with a distance of 1.5 kilometers from the sound will be inaudible. For our research, we plan to build a wind farm at a distance of 13.64 kilometers from the town of Mersing. Thus, this would be a very minor problem. Next, I will pass this to Hanna Najiha for the conclusion. Thank you.
Conclusion. Wind energy is a form of solar energy. Wind power plant is a type of renewable energy and is non-polluting. It is enormous and broadly available as it uses wind as the main source. Wind energy is an effective and reliable source of energy. This energy is converted from mechanical to electrical energy by wind turbines. It can replace fossil fuel heating in a particular area and reduce air pollution. Wind power plant requires high wind speed as it wants to generate electricity. We have chosen Jemaluang Mersing as our project's location. It is located at least 13 km far from the township and near to the sea with the highest mean monthly wind speed in Malaysia. It also requires low energy demand and it is cost effective. This project may have positive impacts as well as negative impacts on the environment and the society. If this project runs properly and continuously managed, its environmental impact may be reduced. With that, I concluded our presentation with thank you.